gotta try. I think I'm on. On right now. That's okay. Oh, we got one person. Oh, lost.
You have to have the chat.
Yeah, just in case. Like some people had questions last time, I didn't get a chance to. Okay, so I guess I can see one person is on. Okay, so good morning. Good morning. So what we're gonna do today is we'll talk about lesson number 4. This is the very last lesson in this booklet. It's a really fast booklet, but there's quite a lot of stuff. Just get started with this. Now, before I begin, what I'm gonna ask you is like for you, give you a few minutes, or not minutes, but a few seconds to just grab a whole bunch of paper, and if yeah, because what we're gonna do is we don't have enough. We'll show our work from there. Okay, so we are on the topic of composite functions, and it says here, use functions f of x, 2x minus 1, and g of x is x squared minus 2. Now I'm the one who doesn't have paper. Okay. So it says here, okay, so state the domain of f of x and g of x function. So that means the domain of f of x is an element of real numbers. So that's the set notation. But if you want the interval notation, you can say from negative infinity up to infinity. So that's the domain of f of x. And then the domain of g of x. So domain, that's for this one. Let's put domain of f of x. Now, for the domain of g of x, now we can see that this is equal to the domain there is x is analogy to sketch the y equals to g of f of x and determine the domain of its composite. So what we're going to do is let's figure out the explicit equation of g of f of x. So first, let's take a look at the explicit one. Let's go ahead to do that. G. Now, yesterday when we talked about this, we said we start from the inner all the way to the out. So f of x, we're going to put 2x minus 1 because f of x is 2x minus 1. Now what we're going to do is we're going to think of this as your x value, and then we're going to operate under the function g. So that means wherever we find x, g of x with 2x minus 1. So every place that we see x, in g of x, we're going to replace it with 2x minus 1. So that means it's right there. So instead of x, okay, instead of x, we're going to put 2x minus 1 there, right there, squared minus 2. Okay, so that's 2x minus 1 squared. We can expand that, certainly. That becomes 4x squared minus um, 4x. That's this one right there, and minus 4x minus 2. Okay, so the composite function. So the domain, therefore, the domain is x as an element of real numbers, or from negative infinity up to positive infinity. Okay. Now I'm not gonna take a lot of time in here. So I've already pre-prepared this example, the graph of it using a technology. I actually use Desmos, and I've mentioned Desmos a few times in our class. Show us that. Okay, so this is what, as you can see, and then the domain here is from negative infinity to positive infinity. Okay, okay, so here's the other thing too that we can think about. Remember that because it's a composite function, we're starting off with the function f. So the function f there is the y values of the, the values of f of x. So that's the range. So the range of f of x will be the domain, the g of f of x. So when we think about that, that's what we can think about. That's that part. Now let's take a look at letter C. Do it in a separate sheet of paper. Example 1, letter C. So the very of g of x. So I'm going to start with the inside, so g, and then g of x is x squared minus 2, x squared minus, replace the x and g of x with x squared minus 2. Okay, so in g of x, there's only one x there, so that's this part here. We're going to replace it with x squared minus 2. So it's going to be x squared minus 2 squared. Okay, so this x, we replace it with x squared minus 2. Okay, again, we can clean that up. We can expand it and combine like terms. So let's do that. So x squared minus 2 squared. So x squared squared, that's going to give us x to the fourth, first term, multiply the first minus 2. And as you can see here, there's going to be a common terms, like terms, so we can combine those. So x to the fourth minus 4x squared plus 2. Composite function is or we can say from negative infinity up to infinity. Okay, so again, just to kind of uh, speed things up, okay, because I know it says there use a graphing technology to sketch. I've used Desmos again to graph this one in here, and this is what I got. This is what the polynomial function for x, this graph on our scanned notes as well. Okay. Okay, so we finished example number 1. What we're going to do is we're going to go jump in example number 2. Now, these two are, we have a rational function, and then g of x is a quadratic function. So determine an explicit equation for each composite function and then state its domain. So let's do that. That's example number 2. Okay, question A, minus x. The very first thing that we're going to do, we're going to see, is j of h of x. Okay, so how to do that? So we're going to start with the inside first. What's the inside function? So inside function is 1 over x minus 2. It's going to be 1 over x minus 2. So that one is easy. Now the next part is that um, we're going to evaluate the function. The note here again, 1 minus 2. So wherever we see x, we're going to replace it with 1 over x minus 2. Minus 2. And then I see an x there again, so that means I'm going to replace that with 1 over x minus 2. So I'm going to go ahead and do that. There's a square at the side, so I'm going to square that one. Minus, again, x. I'm going to replace it with 1 over x minus 2. Okay, so to simplify that a little bit further, we can say I can go 1 over, if I square everything inside the bracket, 1 squared is just 1, and then x minus 2 squared is just going to be x minus 2 all squared. And this is minus 1 over x minus 2. Rational expressions in this, so what we can do is simplify it. If you want, we can certainly simplify this further. So let's go ahead and do that. Now, before we do combining of rational expressions, we have to have the same denominator. So the same denominator would be x. This one here, because I only have x minus 2, I'm going to multiply both the numerator by x minus 2 and then the denominator with x minus 2 as well. So that really gives us, it's going to be 1 over x minus 2 squared minus 1 times x minus 2, so it's x minus 2 over x minus 2 squared. And again, I'm going to try to clean it up. So writing it down all in one. So it's x minus 2 squared. It's going to be 1 minus, okay, 1 minus x minus 2. Okay, I have to explain this one here. I have to subtract all of these. So I put it inside the brackets to kind of help me remember I have to subtract all of that. Not just the x, but the x minus 2. So it's going to be 1 minus x minus 2. That becomes, simplify it further. One last one. Negative x plus 3 over x minus 2 squared. So this one, with the numerator of negative x plus 3, and then the x minus 2 squared. Now, again, for the sake of time here, what did I say? Domain. So, well, what are the x values that's allowed? Well, because this is a rational function, so there is, since this gives us, since it gives a rational function, there is a denominator 0. Okay, and that's basically what the non-permissible value is in rational function, is that what will make the denominator 0, because if we divide by 0, we're going to have an undefined. So what would that be? It looks like here the non-permissible value would be x equals to 2, because that will make the denominator 0. So what's the domain? Therefore, the domain, okay, are x element of real numbers. Okay, x, we can pick any values for x with an exception. X cannot equal to positive 2. That. So I'm going to show you, again, for the sake of time, I'm going to show you the printed. So asymptote, okay, sorry, asymptote x is equals to 2. Okay, so like that. And then this is the weird one because it has an asymptote. It's gonna be a horizontal asymptote at um, y axis there, but then it falls back up, and then yeah. So this is still an asymptote. There's a horizontal asymptote there. Okay, that's great. Again, I'll put that on our notes, on our scan notes. Okay, now the next one that we're gonna do is h of j of x. H of j of x. So we're still on example number 2, and this time we're doing letter B. And what we're trying to do is figure out the y equals to h of j of x. That's aside for now. Oh, there's my paper. Okay, so the very first thing that we're gonna do, is figure out the explicit function. So h of j of x. Well, what's the j of x? That's the x squared minus x. Okay. Now that we have that, what we're going to do is we're going to take the function h and function h. You probably know what I'm going to x with x squared minus x. Okay, so that only happens once right there. Okay, so we're going to replace this x with x squared minus x. So let's go ahead and do that. It's going to be 1 over x squared minus x. Okay, so that's that x there. This one right here, we can, of course, clean that up. It's going to be 1 over, again, this becomes the composite gives us a rational function. Now, because it's a rational function, we have to figure out some non-permissible values. So it seems like this one is factorable in the denominator. So let's factor that out. That's pretty straightforward, pretty easy. It's going to be x minus 2, x plus 1. Okay. Having written it like that we can actually see some non-permissible value. So their permissible value are 2 and negative 1. 2 and negative 1. So, okay, so that means any x values are possible, an exception with exception of 2 and negative 1. So therefore, the domain, okay, x is an element of real number with an exception, so but x cannot equal to 2 and x cannot equal to negative 1. Okay, so all numbers are possible except for these two. At these particular points, okay, so there are asymptotes. Okay, I'm going to actually be specific here. There are vertical asymptotes at x equals to 2 and x equals to negative 1. Okay, so here's what the graph looks like About to graph this already. When we talked about rational functions. Okay. Um, so go over here. This is okay. Asymptote at x equals to -1, and then here's another asymptote. Go ahead at y equals to 0. And we know that already because when we look at if we look at the degree of our polynomials, of our numerator and denominator, the degree of the numerator is way less than the degree of the denominator. The degree of the numerator is actually 0. And then the degree of the denominator is 2 because the exponent is 2. So the denominator gets so much bigger, and then the numerator stays at 1. So if we divide it by some huge number, then it's just going to get closer and closer. That one. Okay, I hope it's all good. So that one will also be on our notes for today. Okay, so going back to our booklet, so we have example number 1 and we have example number 2 that we've done. We're going to go to example number 3. So going to be some square roots around here. So let's go ahead and do that one. And let's do 3a. I'm just going to write down f of x is equals to square root of x. And the other one is g of x is equals to negative x squared plus 2x. Okay, just want to make sure root of x and negative x plus 2. Okay. Of f of x. Okay, write down explicit function, explicit form. So y equals to g, okay, g, starting with the inside. What's the inside? F of x is equals to square root of x. So we're going to put square root of x. Okay. I'm going to write a little note here for myself. I'm going to say I'm going to evaluate function g when x is root of x. So that means we're going to replace the x in g of x, okay, in g of x, okay, so y is equals to g of root of x. So, okay, so wherever I see x there, and I see x there, I'm going to replace those x with square root of x. So it's going to be negative. I see the x, so I'm going to replace it with the square root of x. And then I see a square right there, plus 2 times, I'm going to see root of x again. Okay. I guess we can clean that up. So we can say negative square root of x squared. Well, that just gives us an x plus 2 root of 1. This is a combination of some kind of a linear function and a square root function. And how do we do this one? Okay. What we could do, I have the function ready for you, but just to kind of refresh our memory, when we did this with combining functions at the beginning, like lesson 1, we can combine functions. The graph came to be, and then it's just quadratic and it's just rational function. But this one is a combination of 2 different kinds. So what we're going to do is and then we're going to do negative x and 2. Now, before I get started with that, I'm actually going to see if I can sketch this for us by hand, but I also have the Desmos graph. So looking at this one here, what are the possible restrictions? The first part here is negative x. At negative x, we can have anything there. The restriction is going to be over here. X values we can use. Okay. Now, because we're talking about the square root of x, we cannot take the square root of a negative number. So therefore, square root of x has to be greater than or equal to 0. So what we're going to do is we can't pick anything less than 0. That will be our domain. The domain is x is greater than or equal to 0. So any number greater than or equal to 0. Okay, so let's pick a number greater than or equal to 0. So 0, 1, 2, -1, -2, -3, -4, -5. So that one's easy. Now, what we're going to do is times the square root of x. So if forget this column first. So 2 times the square root of 0 would be 0. So if x is 1, okay, now over here, times the square root of 2 is approximately 2.8. 2.8. So approximately 2.8. Okay, and then this one here is going to be 2 times the square root of 3. So 3.5. So approximately 3.5. Okay, and then here, oh, this one's not bad because I'm going to replace x with 4. 2 times the square root of 5. 2 times the square root of 5 is approximately 4.5. Which is that part of the function. To figure out, to combine these two, I can go negative x plus 2 root of x. Well, I got to add these two together now, right? So it's like, so i.e. combining -1 and plus 2 of 2.8, so it's going to be 0.8. This one here, -3 and 3.5 is 0.5. -4 plus 0 is 0. And -5 and 4.5 is -0.5. So now what we can do, okay, we said last time in lesson 1, we can graph the x, and this one will be our y. Okay, so now this one, I actually have something prepared already. Okay, so I'll just show you where things are. So the first one is at 0, 0. Okay, 0, 0. So in this graph here, it's actually right there, 0, 0. The next one is 1, 1. So that's that point that we found. And then the next one that we found would be, well, we can this out, 3 is, and then 4, 4, 0. 4, 0 is right there. And then we said 5 is -5, which is right there. So the graph kind of goes like this, and it will go down. Okay, so that's your graph for 3A. So I did a little bit of work there to kind of show you where that graph came from. Okay, so that one is going to be on our notes as well. Next one, yeah. We got 43, 40. Again, I'm going to just write down f of x. F of x is the square root of x. And g of x is equals to -x squared plus 2x. And then this time for 3b, we need to figure out the f of g of x. Okay, so the very first thing we got to do is to figure out the explicit function, explicit form. So f, starting with the inside, what's the g of x? G of x is negative. And then now what we're going to do is we're going to turn our attention to function f. And it says there, we're going to put a little note for myself here. For f, replace my x with, replace x with, okay, replace x in f of x with negative x squared plus 2x. Okay, so we're operating in the function f. So right here, right there, and it says there square root of negative x squared plus 2x. Now what we're going to do is we have to look um, for any values that will make the inside positive or zero, right? Because, okay, I'm just going to write a little note here. The composite function is a radical function. Okay. So now, because it's a radical function, negative x squared plus 2x has to be greater than or equal to 0. So what we're going to, so um, greater than, has to be greater than 0. But for it to be greater than 0, it's either this is positive and this is positive and the whole thing is positive, or, okay, or this could be negative and then this could be negative, so the whole. Okay, now how can, in chapter 2, okay, so what did we learn in chapter 2? We said that first graph the quadratic function. We graph the quadratic function. Okay, a parabola opening down. Okay, and that becomes negative x minus 2. So that will make it equal to 0. So that is 0 and positive 2. And so the vertex will be in between positive 2 and 0. So that means it's 1. So 1, if x is positive 1. So the graph, okay. So it's helpful that we learn this in chapter 2. Okay. Now after that, we can apply the square root. Okay. So that means we cut off 0. So those are the invariant points. And then this is also invariant point at 1. But then, because between 1 and 0, okay, there's a little bubble. So this is something that we learn in grade in chapter 2. Okay, so okay, I have the nice version already. Okay, so this is what the graph looks like for that function. Okay, so I'm gonna have those lessons ready. Let's take a look at the last bit here. Um, okay, the last bit is gonna be actually pretty easy. Oh, the domain would be from 0 to 2. 0 to 2 only, nothing beyond that. Okay, now let's take a look at example 4, last one. Example number 4, so for each function, determine the possible value functions for f and g so that the f of g of x is that. So we can take a look at this. What we can do is figure out what g of x is and then the f of x. Okay, so in this particular case, we could choose f of x, g of x. Let's take a look at letter B. Letter B, 1 as my g of x. My g of x, that's going to be 2x minus 1. And then use that one to figure out the f of x, 5 there. If I take this and replace it there, then I'm gonna have y equals f of g of x. So okay, so that's finished. That's done. Um, okay, so we finished this lesson number 4. Um, we're done. We're done this chapter. What we can do is, of course, uh, work on our practice questions in here. Okay, and again, if you have any questions, if there's something that you want me to go over, to show you step by step on how to do things, you're okay with this. And if it's not, if you're still having issues, so for now, for the rest of the time, gonna it's gonna be it's gonna be soon. I'm thinking tomorrow, so watch out for those things. Okay.